All right, moving on to a different topic. This was Audacity spectrograms, where the brightness of the color or the lightness of it was supposed to indicate the presence of various frequencies. In this program, the high frequencies are at the top, with them putting about 20,000 hertz at the top, the upper limit of what people can hear. And then they put the low frequencies on the bottom, and that goes down to about 20 hertz, the lowest that people can hear. So the presence of the orange here indicates that we have low frequencies. Where we have darkness, that indicates that frequencies are missing. So this is an effect called filtering. So some of the frequencies are removed from white noise on the left. Just to give an example, I guess, of them, I'll go to Audacity. Audacity has capability of creating white noise. So we're going to generate noise. So this is a generation of white noise. And if I just click spectrogram, we can see what it looks like. Yeah, there's our white noise. Let's look at a selection of it in the FFT. We're going to hit plot spectrum. And now we can see that all the frequencies are there. I would like to be able to zoom out more, but it looks like it won't let me do that. But anyway, that's all the frequencies. Now let's try to remove some. I'm going to remove the high frequencies. I'm going to go to filter, and I want to do what's called a low pass filter, meaning I'm going to remove high frequencies and let the low frequencies stay. Okay, after I apply the filter, we see this kind of diagram, and now we can hear what it sounds like. More like a low rustling wind or like an ocean sound where the high frequencies aren't as clear. But yeah, that's that. So now let's look at the new spectrum. Here is the new spectrum where we can see that the highs have been removed. And so that is the answer here. High frequencies reduced in volume is sample A. Also on the next page, we should say that A is the unfiltered white noise, and C is where the low frequencies are allowed to come through, but the highs are filtered out. In these diagrams in this program, they put 20,000 hertz, the high frequencies on the right, and 0 or 20 hertz on the left. So these are the lows, and these are the highs. Okay, now we'll just try to filter out the lows instead this time. So let's go to another section and apply what's called a high pass filter. So here it's letting the highs through, not the lows. So it sounds like a hiss. And when we look at the spectrum, we see that the lows here are now missing. So the white noise was B, and we see lows are missing in C. And so unfiltered noise is sample A on top, lows are filtered out in B, and highs are filtered in C.